So that is all for random forest. So guys, I'll discuss other classification algorithms with you, and only then I'll show you a demo on the classification algorithms, right? Now, our next algorithm is something known as naive Bayes, right? Naive Bayes is again a supervised classification algorithm which is based on the Bayes theorem. Now, the Bayes theorem basically follows a probabilistic approach. The main idea behind naive Bayes is that the predictor variables in a machine learning model are independent of each other, meaning that the outcome of a model depends on a set of independent variables that have nothing to do with each other, right? Now, a lot of you might ask, why is naive Bayes called naive? Now, usually when I tell anybody about naive Bayes, they keep asking me, why is naive Bayes called naive? So, in real world problems, predictor variables aren't always independent of each other. There is always some correlation between the independent variables. Now, because naive Bayes considers each predictor variable to be independent of any other variable in the model, it is called naive, right? This is an assumption that naive Bayes takes. Now let's understand the math behind the naive Bayes algorithm. So like I mentioned, the principle behind naive Bayes is the Bayes theorem, which is also known as the Bayes rule. Okay, the Bayes theorem is used to calculate the conditional probability, which is nothing but the probability of an event occurring based on information about the events in the past, right? This is the mathematical equation for the Bayes theorem. Now, in this equation, the LHS is nothing but the conditional probability of event A occurring given the event B. P of A is nothing but probability of event A occurring. P of B is probability of event B. And PB of A is nothing but the conditional probability of event B occurring given the event A. Now let's try to understand how naive Bayes works. Now consider this data set of around 1500 observations. Okay, here we have the following output classes. We have either cat, parrot, or turtle. Okay, these are our output classes, and the predictor variables are swim, wings, green color, and sharp teeth. Okay, so basically your type is your output variable, and swim, wings, green, and sharp teeth are your predictor variables. Your output variable has three classes: cat, parrot, and turtle. Okay, now I've summarized this table as shown on the screen. All right, the first thing you can see is the class of type cats shows that out of 500 cats, 450 can swim, right? Meaning that 90% of them can. And zero number of cats have wings, and zero number of cats are green in color, and 500 out of 500 cats have sharp teeth. Okay. Now, coming to parrots, it says 50 out of 500 parrots have true value for swim. Now, guys, obviously this does not hold true in real world, right? I don't think there are any parrots who can swim, but I've just created this data set so that you can understand naive Bayes, right? So meaning that 10% of parrots have true value for swim. Now, all 500 parrots have wings, and 400 out of 500 parrots are green in color, and zero parrots have sharp teeth, right? Coming to the turtle class, all 500 turtles can swim. Zero number of turtles have wings, and out of 500, 100 turtles are green in color, meaning that 20% of the turtles are green in color, and 50 out of 500 turtles have sharp teeth, right? So that's what we understand from this data set. Now, the problem here is we are given a observation over here. Okay, we're given some value for swim, wings, green, and sharp teeth. What we need to do is we need to predict whether the animal is a cat, parrot, or a turtle based on these values, right? So the goal here is to predict whether it is a cat, parrot, or a turtle based on all these defined parameters. Okay, based on the value of swim, wings, green, and sharp teeth, we'll understand whether the animal is a cat, or is it a parrot, or is it a turtle. So if you look at the observation, the variables swim and green have a value of true, right? And the outcome can be any one of the types. It can either be a cat, it can be a parrot, or it can be a turtle. So in order to check if the animal is a cat, all you have to do is you have to calculate the conditional probability at each step. So here what we're doing is we need to calculate the probability that this is a cat given that it can swim and it is green in color. First, we'll calculate the probability that it can swim given that it's a cat into the probability that it is green and the probability of it being green given that it is a cat, and then we'll multiply it with the probability of it being a cat divided by the probability of swim and green. Okay. So guys, I know y'all can calculate the probability. It's quite simple. So once you calculate the probability here, you'll get a direct value of 0. Okay, you'll get a value of 0, meaning that this animal is definitely not a cat. Similarly, if you do this for parrots, you calculate the conditional probability, you'll get a value of 0.0264 divided by probability of swim comma green, right? We don't know this probability. Similarly, if you check this for the turtle, you'll get a probability of 0.066 divided by p swim comma green. Okay. Now for these calculations, the denominator is the same, right? The value of the denominator is the same, and the value of and the probability of it being a turtle is greater than that of a parrot, right? So that's how we can correctly predict that the animal is actually a turtle. All right. So guys, this is how naive bias works. You basically calculate the conditional probability at each step. Whatever classification needs to be done, that has to be calculated through probability. There's a lot of statistic that comes into naive bias. And if you all want to learn more about statistics and probability, I'll leave a link in the description. You all can watch that video as well, right? There I've explained exactly what conditional probability is, and the bias theorem is also explained very well. So you all can check out that video also. And apart from this, if you all have any doubts regarding any of the algorithms, please leave them in the comment section. Okay, I'll solve your doubts. And apart from that, I'll also leave a couple of links for each of the algorithms in the description box. Because if you want more in-depth understanding of each of the algorithms, you can check out that content, right? Since this is a full course video, I have to cover all the topics, and it is hard for me to make you understand in depth of each topic, right? So I'll leave a couple of links in the description box. You can watch those videos as well, right? Make sure you check out the probability and statistics video. All right, so now let's move on and look at our next algorithm, which is the k nearest neighbor algorithm. Now KNN, which basically stands for k nearest neighbor, is again a supervised classification algorithm that classifies a new data point into the target class or the output class depending on the features of its neighboring data points, right? That's why it's called k nearest neighbor. So let's try to understand KNN with a small analogy. Okay, let's say that we want a machine to distinguish between the images of cats and dogs. So to do this, we must input a data set of cat and dog images, and we have to train a model to detect the animal based on certain features. Okay, for example, features such as pointy ears can be used to identify cats, right? Similarly, we can identify dogs based on their long ears. So after studying the data set during the training phase, when a new image is given to the model, the KNN algorithm will classify it into either cats or dogs depending on the similarity in their features. Okay, let's say that a new image has pointy ears. It will classify that image as cat because it is similar to the cat images, because it's similar to its neighbors. In this manner, the KNN algorithm classifies the data points based on how similar they are to their neighboring data points, right? So this is a small example. We'll discuss more about it in the further slides. Now, let me tell you a couple of features of KNN algorithm. So first of all, we know that it is a supervised learning algorithm. It uses labeled input data set to predict the output of the data points. Then it is also one of the simplest machine learning algorithms, and it can be easily implemented for a varied set of problems. Another feature is that it is non-parametric, meaning that it does not take in any assumptions. For example, naive bias is a parametric model because it assumes that all the independent variables are in no way related to each other, right? It has assumptions about the model. K nearest neighbor has no such assumptions. That's why it's considered a non-parametric model. Another feature is that it is a lazy algorithm. Now, lazy algorithm basically is any algorithm that memorizes the training set instead of learning a discriminative function from the training data. Okay. Now, even though KNN is mainly a classification algorithm, it can also be used for regression cases, right? So KNN is actually both a classification and a regression algorithm. but mostly you'll see that it will be used only for classification problems. The most important feature about k nearest neighbor is that it's based on feature similarity with its neighboring data points. All right, you'll understand this in the example that I'm going to tell you. Now, in this image, we have two classes of data, right? We have class A, which is squares, and class B, which are triangles. Now, the problem statement is to assign the new input data point to one of the two classes by using the KNN algorithm. So, the first step in the KNN algorithm is to define the value of K. But what does the K in the KNN algorithm stand for? Now, the K stands for the number of nearest neighbors, and that's why it's got the name k nearest neighbors, right? Now in this image I've defined the value of k as 3. This means that the algorithm will consider the three neighbors that are closest to the new data point in order to decide the class of the new data point. So the closest between the data point is calculated by using measures such as Euclidean distance and Manhattan distance, which I'll be explaining in a while. So at k is equal to 3, the neighbors include two squares and one triangle. So if I were to classify the new data point based on k equal to 3, then it should be assigned to class A, correct? It should be assigned to squares. But what if the k value is set to 7? Here I'm basically telling my algorithm to look for the 7 nearest neighbors and classify the new data point into the class it is most similar to, right? So at k equal to 7, the neighbors include 3 squares and 4 triangles. So if I were to classify the new data point based on k equal to 7, then it would be assigned to class B, since a majority of its neighbors are from class B. Now, this is where a lot of us get confused, right? So, how do we know which k value is the most suitable for k nearest neighbor? Now, there are a couple of methods used to calculate the k value. One of them is known as the elbow method, right? We'll be discussing the elbow method in the upcoming slides. Okay. So, for now, let me just show you the measures that are involved behind KNN. Okay. There's very simple math behind the k nearest neighbor algorithm. So, I'll be discussing the Euclidean distance with you. Now, in this figure, we have to measure the distance between P1 and P2 by using Euclidean distance. I'm sure a lot of you already know what Euclidean distance is. It is something that we learned in 8th or 10th grade, I'm not sure, right? So all you're doing is you're extracting x1. So the formula is basically x2 minus x1 the whole square plus y2 minus y1 the whole square. And the root of that is your Euclidean distance, right? It's as simple as that. So Euclidean distance is used as a measure to check the closeness of data points, right? So basically KNN uses the Euclidean distance to check the closeness of a new data point with its neighbors. So guys, it's as simple as that. KNN makes use of simple measures in order to solve very complex problems. Okay, this is one of the reasons why KNN is such a commonly used algorithm.